Remember Oumuamua? Picture this moment back in October 2017. That elongated visitor from beyond our solar system tumbled through our cosmic neighborhood at extraordinary speeds, leaving scientists absolutely speechless. Its cigar-shaped form rotated chaotically, its surface reflected light like polished metal. And most mysteriously, it accelerated away from our sun without any visible tail or gas emissions to explain the thrust. I was among the researchers who watched this unfold in real time. Harvard astrophysicist Avi Loeb proposed something that made his colleagues uncomfortable. What if Oumuamua wasn't entirely natural? What if it represented a solar sail, a piece of alien technology, riding photons from distant stars? The scientific establishment dismissed this as wild speculation, preferring any natural explanation, however implausible, over entertaining the possibility of artificial origins. But what if Avi was right? What if we missed the signs because we weren't ready to see them? Now, 8 years later, another visitor has arrived. We call it 3I Atlas, marking it as the third confirmed interstellar traveler to cross our threshold. And this one is doing something Oumuamua never did. Something that violates every principle we thought governed objects from beyond our solar system. It's not speeding up as it approaches our sun. It's slowing down. And according to fundamental physics, that should be impossible. Think about what this means for a moment. Natural comets accelerate as solar radiation pushes them. Oumuamua accelerated mysteriously as it departed. But 3 Atlas, it's exhibiting micro-deceleration events, gentle braking maneuvers that no natural process can explain. So is 3 Atlas deliberately trying to stay in our solar system? And if so, what we're witnessing now changes everything we thought we understood about visitors from the stars. What we're seeing might represent the first confirmed evidence of interstellar technology actively maneuvering through our cosmic backyard. 3. I-Atlas is exhibiting micro-deceleration events, gentle, sustained braking maneuvers that violate everything we understand about how objects move through space. Let me explain why this is so profoundly disturbing. Normal comets behave predictably as they approach the sun. Solar radiation strikes their surfaces, heating frozen ices until they sublimate into gas. These outgassing jets act like tiny rocket engines, always pushing the comet away from the sun, always accelerating it faster along its trajectory. That's basic physics. That's what we've observed in thousands of comets throughout recorded history. Oumuamua behaved differently. Certainly, it accelerated away from our sun without any visible tail or gas emissions to explain the thrust. That acceleration mystified us, violated our predictions, and sparked years of heated debate. But critically, it accelerated outward. It behaved anomalously, but still moved in the expected general direction away from solar radiation pressure. Now think about what 3I Atlas is doing. It's slowing down. No natural comet has ever demonstrated sustained deceleration. The physics simply doesn't allow it. Solar radiation pushes objects away from the sun, not toward it. Outgassing jets push material away from the nucleus, accelerating the comet, never breaking it. And gravity pulls objects inward, making them move faster, not slower. There exists no natural mechanism in our current understanding of celestial mechanics that produces a braking effect on an object moving at these velocities through interplanetary space. Yet multiple independent observatories have confirmed what we're witnessing. The James Webb Space Telescope's spectroscopic velocity measurements, ground-based radar tracking arrays, and Doppler shift analysis from Mars orbiters all tell the same impossible story. Between September 23rd and September 26th, 3I Atlas's velocity relative to the sun dropped from 68.2 kilometers per second to 67.9 kilometers s. That's only a 0.3 kilometer s change. Not dramatic braking by any means, but statistically, it's profoundly significant. Natural velocity variations caused by measurement uncertainties or atmospheric effects typically scatter randomly around a mean value. What we're observing shows clear directionality. Sustained deceleration maintained across multiple measurement windows. Avi Lobo stated it bluntly in his latest analysis. This is the smoking gun. Natural processes don't produce sustained deceleration at these velocities. Either we're witnessing exotic physics we fundamentally don't understand, or we're observing active propulsion from a technological artifact. Consider the comparison carefully. Oumuamua accelerated approximately 0.44 kilometers per second in the wrong direction. That was mysterious enough to spark years of investigation. 3I Atlas is decelerating 0.3 kilometers per second in an impossible direction. The magnitude is slightly smaller, yes, but the implication is far more terrifying because the direction of change violates every natural process we know. If 3I Atlas is genuinely slowing down deliberately, what could possibly explain such behavior? Let's examine the three most plausible mechanisms, each more unsettling than the last. Theory 1 proposes a solar sail operating in reverse mode. Instead of using solar radiation pressure to accelerate away from the sun like a conventional sail, imagine orienting a highly reflective surface to act as a cosmic parachute, creating drag against the photon windstreaming from our star. This requires extraordinarily specific orientation, maintaining precise angles relative to incoming sunlight. And here's the fascinating detail. Spectroscopic analysis confirms that 3E Atlas possesses an unusually reflective surface, far more mirror-like than typical comet nuclei. But there's a critical problem. Natural objects tumble chaotically through space. Random rotation should prevent any sustained orientation, yet 3E Atlas rotates with what observers describe as mathematical precision, maintaining stable orientations that shouldn't persist naturally. Theory 2 suggests active propulsion we simply cannot detect from Earth. Perhaps electromagnetic drive systems producing thrust without visible exhaust plumes or ion propulsion technology so subtle that its emissions remain below our instrumental detection thresholds. The mysterious green glow surrounding the nucleus could even represent ionized plasma manipulation, a byproduct of propulsion mechanics we don't recognize. The insurmountable challenge here involves power requirements. Any propulsion system capable of altering velocity at these scales would demand energy sources operating continuously for potentially thousands of years across interstellar distances. Theory 3 points toward gravitational manipulation through precisely timed planetary encounters. The October 3rd flyby past Mars resulted in measurable velocity changes. The upcoming March 2026 passage near Jupiter offers potential for more significant trajectory adjustments. But statistical analysis reveals the timing is impossibly precise, occurring with probability less than 1 in 50,000. If these alignments were truly random coincidence, all three theoretical frameworks converge on one deeply unsettling conclusion. This isn't random cosmic debris drifting aimlessly through our solar neighborhood. If 3I Atlas is braking, it's executing deliberate maneuvers. It's not behaving like a tourist speeding through on a brief visit. It's slowing down methodically, almost like establishing residence, extending his observation window within our system for reasons we can only begin imagining. Let's be absolutely clear about what separates 3I Atlas from every previous interstellar visitor we've encountered, because the differences reveal a disturbing pattern of escalation. Oumuamua arrived first in 2017. It accelerated mysteriously away from our sun. Yes, but that acceleration pointed outward in the expected direction. Even if we couldn't explain the mechanism, it displayed no visible tail or surrounding coma, remaining essentially inactive throughout our brief observation window. Its elongated cigar shape suggested a natural fragment, possibly torn from some distant planetary system. We tracked it for mere days before it vanished forever into the darkness. It left quickly, executing no trajectory corrections, behaving more like debris than anything deliberately controlled. Now consider 3I Atlas in 2025. It's decelerating, braking against every known physical principle, moving in the opposite impossible direction. It displays vigorous activity with a surrounding coma composed of bizarre chemistry. 95% carbon dioxide rather than the water vapor dominating every comet we've studied. Density measurements suggest a possibly hollow interior, contradicting how natural objects form through gravitational collapse. We've observed it continuously for months now, not days. And critically, it adjusts its trajectory at key moments, threading past Venus, Mars, and Jupiter with timing so precise the probability calculates at less than 1 inch 50,000 for random coincidence. Oumuamua tested our detection capabilities, revealing gaps in our monitoring systems. 3. iAtlas is systematically testing our understanding of physics itself. Notice the progressive escalation. First visitor, we thought that's peculiar. Second visitor, Borisov seemed weird, but more conventionally comet-like. Third visitor, we're confronting the impossible. Even Avi's perspective has evolved dramatically. In 2017, he proposed Oumuamua might represent artificial technology and faced ridicule from conservative colleagues. Today, after analyzing 3I Atlas, he states bluntly that this new visitor makes his original Oumuamua hypothesis look conservative by comparison. His statistical analysis now places natural origin probability between 30 and 40% down precipitously from the 90% initial estimates. If Oumuamua was a warning we collectively ignored, 3I Atlas represents the confirmation we absolutely cannot dismiss. In exactly 13 days, we'll know definitively whether 3Y Atlas represents natural cosmic debris or something far more extraordinary. The perihelion test arrives between October 29th and 31st, when the comet reaches its closest approach to our Sun at approximately 1.36 astronomical units. That places it just inside Mars's orbital path, subjecting it to maximum solar heating and radiation bombardment. Natural comets typically respond to this thermal assault in predictable ways. They fragment catastrophically as temperature gradients create mechanical stresses exceeding structural integrity. Or they develop massive spectacular tails as volatile ices sublimate explosively into space. If 3E Atlas survives perihelion completely intact, the probability of artificial origin jumps immediately above 70%. And if it decelerates again during this passage, executing another impossible braking maneuver, then game over. We're no longer discussing natural objects. Consider 3 distinct outcome scenarios. Scenario 1 involves fragmentation. The object breaks apart like conventional comets, releasing debris fragments that drift along slightly divergent trajectories. Mystery solved through mundane explanation. It was merely unusual chemistry combined with fortunate geometric alignment. Scientists worldwide breathe collective sighs of relief. Scenario 2 presents survival intact. No fragmentation despite exposure to extreme thermal conditions. No catastrophic structural failure. This outcome strongly suggests internal architectural reinforcement. Possibly that hollow core structure density measurements have hinted toward the door to artificial possibility swings wide open. Scenario 3 represents the nightmare timeline. 3. iAtlas uses perihelion strategically to adjust its orbital trajectory, executing what aerospace engineers call an orth maneuver. It deliberately exploits the Sun's gravity well at maximum velocity to alter its path with minimal energy expenditure. This would indicate intentional navigation, suggesting the object plans extended residence within our solar system rather than brief transit. Beyond perihelion, December 19th marks our final premium Earth observation window, when the comet passes 167 million miles distant, still visible through amateur telescopes. If velocity measurements continue showing deceleration, we receive our definitive answer. Then Mars 2026 delivers the Jupiter encounter, another gravitational interaction opportunity, another potential trajectory adjustment. If it maneuvers again, artificial origin becomes undeniable. The European Space-Ice JUICE spacecraft will observe this encounter up close. We're essentially witnessing real-time confirmation or denial of interstellar technology's existence. Unlike Oumuamua, which vanished before thorough study 3, I-Atlas grants us months preparing for whatever revelation its behavior ultimately delivers. So here's where we stand. An object from beyond our solar system is behaving in ways that fundamentally violate our understanding of natural physics. Is slowing down when it should accelerate. Its timing appears deliberately precise when it should be random. Its trajectory suggests extended observation when it should represent brief transit. Whether 3I Atlas ultimately proves natural or artificial, it has already accomplished something profound. It's forced our collective consciousness to confront possibilities we've always comfortably dismissed as pure science fiction. The universe doesn't owe us simplicity or easy answers, but it does offer us truth if we possess sufficient courage to pursue it honestly. Subscribe now to follow 3I Atlas through his perihelion passage. Comment below with your prediction, natural or artificial, because October 29th will answer questions that have haunted humanity since Oumuamua first challenged everything we thought we understood about visitors from the stars. Stars,